Welcome back. In this lesson, we're diving into how machines understand text. While we humans naturally process languages, teaching computers to understand text is a fascinating challenge that forms the foundation of many multimodal systems. Let's start with a simple question. How do you understand the meaning of words? When you read a sentence, your brain processes not just individual words, but their relationships, context, and subtle nuances. For computers, we break this process down into several steps. First, we take the raw text, then we break it into meaningful pieces, then we convert these pieces into numbers, and finally, we understand the relationship between these numbers. Let's walk through each step. Here's a simple example of what raw text looks like to a computer. Not very useful, right? Let's see how we transform it. The first step is tokenization, breaking text into meaningful pieces. Think of it like taking a sentence and carefully separating each word or subword, but it's not always as simple as splitting on spaces. Contractions like don't or we're, were, compound words like dataset or machine learning, special characters and punctuations, or even different languages and writing systems, they all pose challenges for tokenization. And so before we can really understand text, we need to clean it up. This pre-processing stage includes converting to lowercase, removing special characters, handling punctuation, and then dealing with stop words. Now comes the fascinating part. How do we convert words into numbers that capture their meaning? This is where word embeddings come in. Imagine a huge multimodal space where every word has its own position. Words with similar meanings are closer together. For example, king and queen would be close, and they'd have a similar relationship as man and woman. We use algorithms like word2vec or glove to create these embeddings. They learn from millions of examples of how words relate to each other. Once we have words as vectors, we can measure how similar they are. Let's look at some common approaches. We have cosine similarity, we have Euclidean distance, and we have dot product. Understanding text is an essential foundation for multimodal systems. When we combine this with other modalities like images or videos, we need these basic building blocks to work effectively. Let's look at a real-world example. When you search for products online, the systems need to understand both the text and the text descriptions and the product images. The text understanding we covered today is what helps match your search query with relevant product descriptions. In our next lesson, we'll see how to combine these text understanding techniques with other modalities. But first, let's do a quick exercise. Try this. Take a paragraph of text and break it down following the steps we covered. Tokenize it, pre-process it, and think about what relationships exist between the words. Understanding text is like giving computers a basic sense of language. In the next lesson, we'll build on this foundation to create more sophisticated understanding systems.